what types of items yung lalabas because it has been different from year to year. So what we're going to do is we're going to stick with the items na binigay na sa atin from the previous 3 exams. And then we're going to try to cover as many concepts there. So from now until 6, we'll discuss LE1, and then we'll have a short break. LE2 and 3 will discuss mamayang 7 to 9. And then the last hour will be buffer time or Q&A time if you guys have any questions outside what is discussed. Okay, so I guess with that out of the way, we can start with LU1. So LU1 is mostly just introduction to linear algebra matrices and how to work with them. So I guess just so you have a snapshot of what we're going to cover specifically, and so that in your own study time, you know what to cover then. This is what the coverage of LE1 was, or Unit 1 was. So just fundamentals ng matrices, matrices as systems of linear equations and how to solve them, and then determinants, related operations to that. So with that out of the way, and we'll send a copy of this naman after the session, so don't worry. You don't have to like screenshot, or if you prefer to screenshot it, I don't mind. So let's discuss LU1, and I will first discuss the first problem. So this was the first problem, system of linear equations siya, and we're asked to find the values of k that provide unique solutions, non-unique solutions, and no solutions. So just to put into context the problem, we have to recall 2 important concepts, which are submatrices and rank. So submatrices are basically just smaller matrices inside the large matrix. So for example, if I take an arbitrary part of this augmented matrix, this part, this is a submatrix of matrix A. But obviously this can also be like there are different combinations of it. So this can also be a submatrix of A. These are both different submatrices of A. And these 2 in particular, the one that covers the left part and the right part, will be important because these will help determine rank. So rank naman is the largest order of square matrix. So the largest square matrix you can place inside, like you can place inside the matrix na you're evaluating kung ano yung rank. So for example, if this whole submatrix has a determinant not 0, we can say na matrix A has rank 3, and that will be important in discussing the latter the types of solutions. Kasi for unique, non-unique, and inconsistent solution, it depends on what the rank of the original matrix is and the augmented matrix is. So the original matrix is this part, yung walang line, and then the augmented matrix is this whole thing, including na yung right-hand side. Kasi, diba, this is just, technically, this is like rewritten lang as yung original matrix nandito, and then you have x1, x2, etc. And then you have the right-hand side. So parang you just smush them together. That's the augmented matrix. So just a refresher in case we needed to recall that. So given that, for unique solution, it's just rank ng A should be equal to rank of A augmented B equal to n, where n is the number of rows. Same thing with non-unique. Kailangan rank A is equal to rank A augmented B, but it has to be less than the number of rows. And then inconsistent naman if the rank of A is less than the rank of A augmented B. So that might be hard to visualize now. So let's just tackle problem 1 para mas magets natin. So now, let's solve problem 1. So the first thing we want to do is figure out the most efficient way to solve this, to find the rank. And to find the rank, we need to find the determinant. So the most efficient way to do that is by changing this matrix into a triangular matrix. Kasi the determinant of any triangular matrix is just the diagonal. So it's just this part. Pero first, we have to convert this into an upper triangular matrix. So we're gonna use reduced row echelon form, and we're gonna do some row operations. So I wanna remove these three basically. So I wanna take these three out, and what I'm gonna do is I'll first focus on the first column. So this section muna. Let me just erase that para malinaw. Yan. So I want to remove k squared. So the way I'll do that is I'll set row 2 prime to be equal to row 2 minus row 1. And so that we're efficient na, we can just also change the third row na rin. So R3 prime is equal to R3 plus R1. So this will effectively remove both of those. So let's see ano mangyari. So that's k squared. Just copy the first row. And then second row, R2 minus R1. So k squared minus k squared is 0. K plus 3 minus 1 is k plus 2. 2 minus 1 is 1. 1 minus 1 is 0. For the third row, R3 plus R1, negative k squared plus k squared is 0. Negative 1 plus 1 is 0. So it's actually convenient. Hindi na natin yun isipin. So k squared minus 2 plus 1 is k squared minus 1 equals k squared plus 2k. So as you can see, this is now in reduced row echelon form. So now we can basically go from here, figure out the values to get a unique solution, non-unique solution, no solution. So let's first start by finding the values of k such that we'll have unique solutions. So again, bring back natin yung conditions for a unique solution. So for a unique solution, we want the rank of A to be the rank of A augmented B equals n. So in this case, n is 3 because it has 3 rows. The next thing we want to figure out is what are the conditions for the rank of A to be 3 and for the rank of A augmented B to be 3. So ibaba ko lang to. So now, let's first look at the rank of A because it's easier. So again, the rank is the highest submatrix that you can put inside the matrix that still has a non-zero determinant. So what this means is since we want a rank of 3, we want this entire submatrix because, oh yeah, one thing pala, like just for baka lalabas sa true or false or whatever, like true or false part or whatever. A matrix is a submatrix of itself. So yeah, we want this entire thing because this has order 3 square matrix. We want this to have a non-zero determinant. And since it is upper triangular, the determinant of this matrix A is equal to the elements lang along the diagonal. So k squared minus 1. Ayan. So basically, for the rank of A to be 3, the determinant cannot be 0. Kasi if the determinant becomes 0, we're sure na it's not rank 3. It could be rank 2 or 1. Pero all we know is that it can't be rank 3. So the determinant cannot be 0. And therefore, since the determinant cannot be 0, this whole statement, which is the determinant of A, and then I'll just break this up na into k plus 1, k minus 1. This cannot be 0. So this is for the left-hand side, yung sa sa rank of A. The next naman we'll figure out is the rank of AB, which is basically just this. Kasi it's the largest square matrix na we can put inside. So if you look at it, it kind of has the same conditions na none of the terms na may k can be zero. Because let's say if uh let's say if this becomes if this becomes zero, what basically happens is uh yeah, if this becomes zero, bawal yan. If that becomes zero, bawal yan. Okay, so okay, yeah. So we also want that this term does not become zero. So factoring this out lang. And wait. Okay. I forgot to add one pala here. Sorry. So plus one dapat yan. So breaking this up further, this will become k plus 1 squared. So for the A augmented B, para hindi siya maging rank 2 or lower, so it stays rank 3, k cannot also be -1. So that's all, that's covered here na though. Pero usually you have to check both sides. Sadyang this instance, same lang siya. So TLDR nitong lahat, for to have a unique solution, k cannot be 0. So from this, -2 from this, -1 from this, or +1 from this. So yung technical final answer dito is k for any real number k excluding 0, -2, -1, 1 will yield a unique solution. Yeah, so that's for yung unique solution, which is yung first part. So yeah, now na we figured out which numbers yield a unique solution, usually that's a clue na for non-unique and inconsistent solution. Kasi basically, there's a property na all real numbers that are possible for k either have to be a unique solution, yield a unique solution, non-unique solution, or inconsistent solution. So bale, you have to cover all the real numbers. So if these are the 4 na lang that are not covered yet, and then that's a clue na for what numbers you should be getting sa next items. So let's move on to the next items. So for non-unique, i-copy ko lang yung matrix so we can save time. For non-unique naman, the condition here is na equal yung rank nila, but it has to be less than n. So we've established na kung mag-zero yung isang term of k here, magkakaroon ka ng situation na the rank is less than n. So we just now have to make sure na kung bababa yung rank ni A, bababa din yung rank ni A augmented B. And the way we make sure that happens is kailangan nagpapa-zero siya ng one of the terms here, and at the same time nagpapa-zero siya ng term dito. So rechecking lang yung factors nito. So again, breaking this down, this is just k plus 1 squared. This is k plus 1, k minus 1. This is k plus 2. This is just k squared. So makita natin na k plus 1 is a common factor between the two. So what that implies is na when k is equal to -1, when k is equal to -1, mag-zero to siya. So here and here. And then basically when you check for the rank by checking the determinants of yung submatrices, you will end up with a situation na less than 3 siya. So again, n is 3 for our example. So okay, let's just do that manually. Like i-demonstrate lang natin. So this is 1 0 0 1 1 0 1 1 0, and then this is 1 0 0. Okay, so let's check for the rank. Let's check for the rank of A first. So before augmented B muna. So again, this is A, this is B. We check for the rank of A. As you can see, yung bottom row niya is bottom row. So row 3 is all zeros. And from the properties of determinants, that means na the determinant, kapag may row ka or column na puro zero, that means na the determinant of the whole matrix is zero. So that means na here pa lang, the determinant of A is zero. So therefore, hindi siya rank 3 matrix. If you pick a smaller submatrix, so let's say ito, if you check for the determinant, diagonal method lang, 1 times 1, positive 1, minus 1 times 0, which is 0. So now, the determinant of this 2 by 2 submatrix is 1. So that implies na the rank of A here is 2. So let's check if it's the same. Kasi yun nga yung, so na fulfill natin yung condition na rank of A is less than n, less than 3. Let's check if rank A is equal to rank A augmented B. In this case, we can pick this ulit. For this naman, as you can see, same thing. Yung isang buong row is 0. So by the properties of determinants, the determinant here is 0. And therefore, yung rank niya cannot be 3. Let's check if it's 2 kasi that's what we got kanina. Let's pick this arbitrary submatrix. Again, the submatrices na you'll pick is arbitrary. So just make sure to double check if my case na like you don't get the answer you want agad. It might just be a case of choosing the wrong submatrix. You have to test for all of them. In this case naman, let's pick the upper left. So 1 times 0, 0, minus 1 times 1, just 1. So diagonal method lang ulit. And so the determinant of this submatrix is negative 1, which is not 0. And therefore, yung rank niya is 2 kasi this is a 2 by 2 submatrix. So the rank of A augmented B is 2. And therefore, this is correct. And we can now conclude na for K equals negative 1, K equals negative 1 yields a non-unique solution. Yeah. Okay. So that's for the second part. For the third part naman, for inconsistent, going back lang to how we can use the information na we got previously. Nakuha na natin na negative 1 gives an inconsistent solution. So what we're expecting na is that the other items will also yield inconsistent. The other items will yield inconsistent solutions. So let's test if that's the case. Plug in lang natin ulit yung matrix. So I'll copy this again. Okay. So going back to this. Okay. So let's just test the other values. So usually at this point you can plug and play na lang and then evaluate the rank. So let's test K equals 0. 0, 0, 0, 1, 0, 1, 1. And then 1, 0, 1. So testing here ulit. This will give you a determinant of 0. So the rank is not 3. So we can pick a smaller submatrix. This will give you 1 minus 2. So negative 1. So non-zero siya. So the rank is 2. But for the right-hand side, if you test ulit this submatrix, you can use whichever method you want here. I will use cofactor expansion, so we can review that na rin. So expanding along this column, we have 1 times negative 1 raised to row 1 plus column 3. Tapos the determinant of whatever remains. So cross out tong dalawa, 2, 0, 1, negative 1, plus 1 time. So we cross this out. So now we repeat the process. 1, so magka-cross tayo dito, times negative 1, third row plus third column, times the determinant of what remained. So ito, 1, 1, 2, 1. If you solve for this, so these are both even, so magiging positive 1 lang yan. So effectively, magka-cancel lang kasi puro 1 siya. And then this is negative 2 minus 0, so negative 2. This is uh, 0 minus 2, so negative 1. So if you add them together, the determinant of A augmented B is equal to negative 2 minus 1 equals negative 3. And that's since that's not 0, the rank of A augmented B is equal to 3. So the rank of A is 2, the rank of A augmented B is 3. The rank of A is less than the rank of A augmented B. And therefore, tama nga na this will yield an inconsistent solution. But I have run out of space, so let me make some space for it. Yeah. Okay. Continuing, we'll try the other values. So tapos na tayo with negative 1. Tapos na tayo with 0. Let's try negative 2 and 1. So for k equals negative 2, actually you can just plug all of this in. Pero once you evaluate it na, so k equals negative 2, 4, 0, 0, 1, so negative 2, 1, 0, 0, 1, 1, 3, and then, oops, sorry. And then 1, 0, 1. Plugging this in, you can test yourself, pero magkakaroon ka ng rank 2 dito and rank 3 dito. So once you do the same tests we did, that means na rank of A is less than rank of A augmented B ulit. And you can also test this for k equals negative 2 at k equals 0, which is so 0, negative 2, positive 1 pala. For k equals positive 1. So yung mangyayari dito is this just becomes 1, 0, 0, 1, 3, 0, 1, 1, 0. And then this becomes 1, 0, 0, 1, 0, 1. So if you test this then, you're also going to reach the same outcome. You can tell na dito from laws of determinants na it can't be rank 3. So this is rank 2, and this is also rank 3. So basically, you will, so for k equals 0, negative 2, and 1, you will yield an inconsistent solution. So then that's the conclusion of the ano. So that's basically the final answer. This will yield a unique solution. This will yield a non-unique solution. And this will yield an inconsistent solution. So yeah, to summarize it lang, again, make sure you're doing it naka-triangular matrix siya, usually upper triangular. So just use the row operations. And then once you solve for unique solution, usually through usually by checking kung saan magzi-zero yung determinant, you will usually find like na it's basically all real numbers minus certain list of numbers. And then you can just use that list of numbers to check if you're able to get a non-unique or inconsistent solution. So that's basically it from me. We can, since it's 5:30ish na rin, let's move on to problem 2, which is Jerome's. So I will hand it off to him.
Hello. Okay, hold on. I am having share screen difficulties, so while waiting, If you have any questions to ask about this problem, go ahead. But I'll just fix this. Okay. Yeah. Hello. So if everyone is G with what you discussed, let's continue to number two. So let's start off first with the concepts you're gonna need for number two. It's here on the left if nakalimutan niya na. So concepts you'll need to remember are matrix multiplication. This is kind of like what's the word? Foundational. So please make sure na marunong na kayo dito or else you will struggle. Um, so basically for matrix multiplication, if you have a okay, kita naman. If you have a matrix C that is a product of A and B, then just remember this will help you keep yourself on track na element ij, where I is the row number and j is the column number, is basically just the dot product of row I of the first matrix and column j of the second matrix. So when I get confused with matrix multiplication, this one line is what keeps me on track to remember what matrix multiplication is. And just remember na the dimensions, there are certain conditions for the dimensions of the two matrices for the matrix multiplication to be valid. So if the first matrix has dimensions m by n and the second one has q by r, n should be equal to q. Basically, the number of columns of the first should be equal to the number of rows of the second. And then we have inverse matrices. And then this one's pretty easy. Basically, you can think of it, it neutralizes, it turns the certain matrix into the identity matrix. So not every matrix has an inverse, but if it does, then the product of a matrix and its inverse is the identity matrix. And then lower and upper triangular matrices. This is basically just terminology. So lower and upper triangular depends if parang the elements above or below the diagonal are all zero. There's also diagonal matrices, which are both lower and upper triangular. And LU factorization, medyo may pagka-memorize din dito. Um, you don't really need this whole thing for the item I'm gonna discuss, but it's good to remember for the finals. And then Kramer's rule, where basically if you're finding out unknowns, it's gonna be equal to the determinant of your modified matrix, where you put the. So I'm gonna demonstrate it later, pero alam niyo na to. Just remember this formula. So to start off with the solution, the first thing we can do, um, the nice thing about, nice thing, I guess the fun thing about problem 2 and problem 3 of LE1 is very much deduction siya. So it's kind of like um, a mystery. You're solving a mystery. So the first clue that we can use immediately is that you can see here, the inverse of A is a lower triangular matrix, and then they give us the following matrix, which shows inverse of A, but with some unknowns. So since inverse of A is lower triangular, then this stuff, these elements above the diagonal, should be equal to zero. So yeah, that's the first step. I'm sure most of you probably got that. And then they also tell us that B times the inverse of A is the LU factorization of this matrix. And then they also give us B. So it's kind of straightforward. Just B times A inverse of A is equal to C. So you can write it out like this. This is B. This is A, or what we know of A so far. And then this is matrix C, or what we know of it. So The thing about this item is actually you don't need to know these little unknowns here on the bottom. You can solve for them if you want to be safe. I did solve for them, but I found out you don't actually need them. So basically, the principal thing that's gonna guide you is the knowledge of systems of equations from like high school or whatever. Since we still don't know our entire inverse of A. We don't know A, we don't know D, and we don't know E. We have three unknowns. So that means we want to get from this whole thing, from doing, we want to use this equation to get three more equations that are like not matrix equations, but algebraic equations. So uh, the good thing about B being a diagonal matrix, so there's a lot of zeros, you can actually target na you isolate the your unknowns. So since we know na matrix multiplication does like row times column, we know na if we want to get this, um, we want to get something in the second row here, or yeah, if you want to get something in the second row here, it should be, we should multiply, we should use a cell in the product column which utilizes something from the second. Okay, imagine ang complicated ng phrasing ko, but I think it's easier to notice in practice. So basically, let's start here with D11. So the top left element in the product matrix. So, which is 2e minus 1. But we know that 2e minus 1 is equal to row 1 of B, the dot product of row 1 of B and column 1 of A inverse. And the neat thing about this is since row 1 of B is 1, 0, 0, column 1 of A is A, D, 0. Since there's 0 here, or since everything is 0 except for one of these, you're going to end up isolating A. You're going to find out that A is equal to 2e minus 1. And then for D, 2, 1, row 2 of B times column 1 of A inverse, you end up isolating D. So you find out 2D is equal to E minus 3A. So using the same method, you find also na 2E equals 2. So you have three equations relating A, D, and E to each other. So using algebra, you will be able to solve for the values of A, D, and E, and you'll be able to solve the entire A inverse matrix. Um, Technically, since this is a system of equations, I'm not sure if it was required to use Cramer's rule to solve it. I did use Cramer's rule, but in the interest of time, we're not going to do that right now. But I'll demonstrate it for the next part of this item. So knowing that a matrix times its inverse is equal to the identity matrix, and you can also do this backwards. An inverse times its respective matrix is also equal to the identity matrix. We can do this. So this is A inverse, and then this is the A that we're looking for, and then this is an identity matrix in 3 by 3 form. So this is where most people got confused because basically they're asking you to do Cramer's rule, but we only know how to do Cramer's rule when the unknown side is a column. So the neat thing, actually kita nyo nasa baba, is pag ganito, you can split it into a matrix times a column. Because if you remember in let's say every item in this column, um, like the definition of matrix multiplication, basically. For example, this one is row one, dot product of row one of A inverse and the column one of A. And then basically column dot product of something and row column one of A, dot product of something, column one of A. So notice that all of these are the dot product of something and column one of A. So you can split this operation into three column multiplication. And then that's when we're going to use Cramer's rule. So basically we got the first column in the unknown matrix and then the first column in our identity, and then second column here, and then second column goes there also, and then third column, third column. Yay. So now that we have this setup, we can do Kramer's on it. And so we saw the formula kanina. So to get all of these unknowns, you want to do like yung A, I over A, where in this case, usually the first step is you solve for A first. And then you, since you can see from this, it's a triangular matrix. Fancy thing about triangular matrices, its determinant is just the product of all the elements on the diagonal. So since our determinant of A is just one, then luckily all of these A11, A21, A31, they're just gonna be equal to, ay, sinulat ko pala dito. So each Aij equals Ai since Aij, yeah, yeah. So I did a sample here. So for A11, we just got our AI here is gonna be, if you replace the first column with this matrix on the right, naka-color code naman siya guys. Kaya na yan. So you get the determinant of that, A11 equals 1. And then here, for the second unknown, you instead replace the second column with this one. And then for the third unknown, you replace the third column with this one. Then use the same method to get all of the rest of it. That is left up to practice for the reader. Anyway, so then you can get the final matrix A equals this thing. Mukha siyang staircase. Staircase to heaven. Thank you. Any questions? If wala, can move on. But I will just drink some water. Okay, guys. Send a heart a react if you're ready to move on to number 3. Okay. Thank you sa lahat na handa na mag-move on. Okay. If you have questions, you can ask naman anytime, anywhere. So LE1, number 3. So for problem 3, concepts that we need to remember are the determinant methods. So there's the definition of the determinant. So yung may kinalaman sa like permutations and stuff. Can explain more about that later. And then triangular diagonal, we mentioned this kanina. Cofactor method, I think Hugh did that in his first item, but I can also review it mamaya. And theorems on determinants. So there's a lot of these, but the ones that we use in this item are this one. The determinant of a product times the determinant of a constant times a matrix is the determinant of that matrix times the constant to the power of how many rows it has or how many columns, because it should be square, so same lang naman. And then eto, if we add the columns to each other or rows to each other, same lang yung matrix, same lang yung determinant. And then other laws or theorems that you'll need to remember, but not for this item. Okay. Spoiler. I mean, nakasulat naman lahat. So we're given 4 pieces of information. A equals 3D, then they gave us sort of the A matrix, sort of the B matrix, and sort of the C matrix. So finding A, this is another like scavenger hunt type thing. Remember that the determinants are real numbers. So when you're looking for the determinant of that, when we're looking for the determinant of A, and we have 4 determinants to be concerned with. Ay, 4 ba? Yeah, 4 determinants, A, B, C, and D. We know we're also going to be looking for 4 equations before we can do anything. So the first equation we can get, which is one of the most simple one from the given, determinant of A is equal to the determinant of 3D. And then from here, the given B matrix, they showed us that D is a 2 by 2 matrix. So that means the determinant of A is equal to 3 to the power of 2 times the determinant of D. So I highlighted it. This is our first equation of the night. Well, obviously not of the whole night. Okay, so we can move on to solving or getting what we can from our next clue, which is the A matrix. So we know that the determinant of A is equal to the determinant of what they gave us. But what they gave us has a lot of unknowns also. I'm sorry. Okay, thank you, Hugh. Has a lot of unknowns also. But since we know we're looking for equations naman, now we won't have our answer immediately. Let's just go with it and see what we can get. So what you're gonna do here is do row operations until, for me, the easiest way is do it until it's diagonal. I'm not sure if there's another way to do this, but basically you do it until diagonal. And then you can see na all the row operations I do here are just adding rows to each other. So the determinant does not change. So I ended up with this matrix where the diagonal elements are determinant of A minus determinant of C minus determinant of V and -1 and -1. So that means the determinant of A, remember that this is the A matrix, is equal to the product here. And then you're gonna get here A minus C minus B equals A. A is on both sides, just cancel algebra. Hooray! You're gonna find out that C, determinant of C plus the determinant of B is equal to 0. And then that's our second equation in our system. And then now what are we gonna do with matrix B? The biggest problem with matrix B is there's a lot of unknowns. And like unlike in other ones where the unknown is a determinant itself, we have these unknowns which are just black boxes that you basically might never find out what they are. And then we also have this huge unknown, which is the entire D matrix. Luckily for us, we don't actually need to know what the D matrix is. We just need to find out its determinant or relate its determinant to the determinant of the other matrices. So we want to isolate this D thing using the cofactor method. So since the cofactor method is like, sinulat ko ba dito? Okay, yeah, it's like the sum of, oops, the 1 times, okay, yun, Aij. Since it's the sum of basically the product of the cell that you chose and its sa may tawag dito, yung something something complementary minor ata. And then so when you do cofactor method, usually you want to choose a row that has many zeros. And our best case is if everything except one element is a zero. So for here, we can do, we're basically just choosing between 2 or 3 since everything else is 0 or unknown. We can't use 3 because on both its column and its row, there is an unknown. We can't be sure that this is a 0. We can't be sure that these are zeros. That's why we do it first on the row of 2 since lahat ng kasama niya sa row are zeros. So when we do this, we eliminate the column of 2 and the row of 2. So yung magiging resulting um, matrix that we're dealing with is this one. And then we know that from our thingamajig, from cofactor method, this is just going to be 2, the element that we had, times -1 to the power of I plus j, since this is on row 1, column 2. That's 1 plus 2. That's 3, obviously. Anyway, so we have still this matrix that we have unknowns in, so we still can't solve it completely. But luckily, since now that we eliminated this column, row 3 also has only zeros on its row. So you eliminate the column and row of 3, and then basically do a double cofactor method where we do our original thing and then times 3 times -1. And then in this matrix where it comes from, 3 is in row 3, column 1. Even though in the original, it's row 4. Since we're referring to this one, it's row 3, column 1. So 3 plus 1, 4. And then times. After we eliminate this, all that's going to be left is the determinant of D. So after you solve all of this, you're going to find that determinant of B is equal to -6 times the determinant of D. And moving on to the next clue that we have, since we were able to get a equation already. Our next clue that we have is the C matrix. So it's this thing, and then first thing you do, check if there's any rows na everything is zero or everything is zero except one. Actually, in this case, even if everything was zero, mahirapan ka pa rin because, you know, you still have to keep going down the grid because you're only reducing it by one column and one row. So usually, so since it's very big, 5 by 5, can't do anything about it except since we have a lot of zeros, we use the definition. So the permutations I was talking about kanina, I finally have to talk about it for real. Basically, you're gonna go through every row, row 1, row 2, row 3, row 4, row 5, and then you pick a column that you're gonna that's gonna be part of the product. And if you chose column 1 for row 1, you can't choose it for the next ones. And then if you chose, yeah, basta, gets in. I think a lot of people refer to this as yung parang Sudoku, which is true. Um, Basically, when you have permutations, you're gonna add up all of the possible ways that you can choose columns for each row. But since maraming may zero, you know that permutations where a certain zero is chosen, since product siya, if you remember, over here, product siya, that entire term is gonna be canceled out. We don't have to worry about it. So instead, for a row, find out which columns have non-zero elements. So for here, we don't know if B or D is zero, but we don't know it. So let's just include it anyway. So for row 1, 1, 4, 5, columns 1, 4, 5 are non-zero. And then I won't go through it, I'll get in the end. So these are all the non-zero columns for each row. So what you want to do is just make like a chart. Like it's kind of brute force, but it's the best way you're gonna find out all the possible permutations. So starting with choosing row 1, I choosing column 1 for row 1. That means you can only choose column 5 for row 2. Then you can either choose 2 or 4 for row 3. And then let's go here. If we chose 2, you can only choose you can only choose 3 for row 4. And then that means you can only choose 1 for row 5. But the problem here is that 1 is already chosen at the start. So this entire branch is, well, it's not part. And then let's go back to here. If you chose 4, you can choose either 2 or 3. And if you chose 3, you can only choose 1, which again is a repeat. And then if you chose 2, you can choose either 1 or 3, but we've established so many times we don't want to choose 1 again. So from this branch, starting from if you choose 1 at the start, you actually only end up with one permutation, 1, 5, 4, 2, 3. And I would like to show you the process for all of the other permutations, but we are running out of time. So I'll just say that if you continue that for every pass for all the branches that you can make, you're gonna get only 3 permutations, which is great. So you have 1, 5, 4, 2, 3, 4, 5, 2, 3, 1, 5, 1, 4, 2, 3. Then if to determine whether it's positive or negative in the determinant, we count the number of inversions. So inversions is how many times does an, a number greater than something, does a number come before a number less than it? Mm-hmm. I think gets it about yun. Sana. So basically 5 came before 4 and 2 and 3. So there's 3 inversions here. 4 came before 2 and 4 came before 3. So there's 2 more inversions here. So there's 5 inversions here. Then same thing. Ah, let's count the number of inversions. This for this one, it's 8. Then 1, 2, 3, 4, 5, 6. Then this one is 6. So this is how you're gonna set them up. So you see that's A1, 2, 3, 4, 5. All of these are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then what's gonna change is the column per for each row. Gets naman, gets naman. So you see here 1, 5, 4, 2, 3. That's our 1, 5, 4, 2, 3 permutation. And since it's an odd has odd inversions, it's negative in the sum. So yeah, if you do all that, you just get it, get those respective elements from the matrix. You'll find that you'll get the equation rather. Now the determinant of C is equal to 4 plus 2 times the determinant of B minus 2 times the determinant of D. So we have a system of four equations where the determinant of A equals 9 to C, and C plus B equals 0, C equals 4 plus 2B minus 2D, and B equals negative 6D. If you just solve that algebraically, treating the determinants as unknowns, like basically unknowns A, B, C, D, you learn that the determinant of A is equal to 9/5, which is the final answer. Yun lang. Scary. Ay, sorry. Saan to nang, DM pala yan. From 9 minutes ago, saan nang galing yung 3 squared? Sana andito pa yung nagtanong. So, itong 3 squared. Uh, this is from the theorem on determinants. Asan na yun? Here. So when you have determinant of a constant times a matrix, you can take out the constant, but you have to raise it to the number of rows that it has. So they showed us in this matrix, in matrix B, that D is a 2 by 2 matrix. So we know that when we take out the 3, we have to raise it to 2. Kaya 3 squared. Yun lang. Hello, everyone. So this is a re-recording of LE2 problem 1 kasi di siya naka-record during the session. So for LE2 problem 1, here's the question. Here are the concepts you'll need to remember. So there's linear combinations, linear transformations, eigenvectors, and eigenvalues, similar matrices, diagonalization, and matrix exponentiation. Medyo madami. Okay, so for linear combinations, it's basically given two vectors, in this case, x1 and x2. uh, Linear combinations are the ways in which you can combine multiples of these two vectors, um, where it's multiplied by these constants c1 and c2. And then other things to note is that if there are no linear combinations other than when c1 and c2 are both 0, where the the linear combination will be equal to the 0 vector, then those two vectors x1 and x2 are considered linearly independent. As for linear transformations are basically analogous or similar to functions in our normal math, or also in programming. You can kind of think of it that way if you're into that. Anyway, so linear transformations are closed under addition and multiplication, which is a property we'll be applying later. Also worth noting, linear transformations are you should be able to express them in terms or as a matrix. Then eigenvectors and eigenvalues are intrinsically linked to linear transformations. Basically, eigenvectors and eigenvalues are associated with a specific linear transformation. So when you for if you have a vector now, when you put it under a certain linear transformation, that vector is simply scaled rather than any other kind of complicated transformation, then that vector is considered an eigenvector of that linear transformation. And then the scale to which it changes is the eigenvalue of that eigenvector associated with that eigenvector of the linear transformation. Then similar matrices. um, Basically, these are a bit complicated to describe, but from the slides you'll see first of all, a property of similar matrices is they have the same eigenvalues. And here in this equation, D equals the inverse of C times A times C. If there exists a matrix C such that this is true, where D is also going to be a diagonal matrix, that's why it's D, then D and A are similar matrices. Diagonalization is basically getting a similar matrix where the D matrix here is going to be a diagonal matrix where the diagonal elements are the eigenvalues of A, and then C is going to be the matrix containing the corresponding eigenvectors. Then for matrix exponentiation, you're also going to be applying diagonalization and similar matrices. So we're taking advantage of the fact that the matrix that A is going to be similar to is diagonal, meaning that when we exponentiate it, you just exponentiate the elements on the diagonal as shown here. So you can see here now a to the fourth power is equal to just c times d to the fourth power times c to the negative one. Actually, negative one, the c inverse. Okay, so for the solution of problem one itself, first question is find a linear combination of x1 and x2 equal to the matrix, column matrix 1, 1, where x1 and x2 are both column matrices. X1 is negative 1, 3, and x2 is 2, negative 4. So when you're trying to find a linear combination here, basically this is the most raw or direct translation of what we're looking for. We want this thing to be equal to 1, 1. But you can also express this as this, a 2 by 2 matrix where the columns are the vectors. So we can solve for C1 and C2 as if it were just our normal matrix operations like Gauss-Jordan and stuff. So you can just do all that. You can augment the matrix here and then change it until you have a workable matrix. Here you can isolate C2. So you know that 2C2 equals 2, meaning 2C2 equals 4. So C2 equals 2. Then you can just solve for the next where C1 is going to be 3. So based on that, you know that the linear combination of x1 and x2 that will result in the vector or column matrix 1, 1 is 3x1 plus 2x2, or here you can express it as 3 times its respective column matrix and plus 2 times x2's respective column matrix. Now, for number 2, let x1 and x2 be eigenvectors of T with eigenvalues 0 and 5 respectively. Evaluate the transformation on 1, 1 without solving for the transformation matrix. So this is where there will be, I want to say heavy application, but it's not super heavy, but just application of the definition and properties of eigenvalues and eigenvectors and the properties of linear transformations. So first of all, the fact that we're transforming the column vector 1, 1 is a hint that we're going to be applying what we did before, because what we did before is also related to the column matrix 1, 1. So since we have a linear we're able to express 1, 1 as a linear combination of x1 and x2. We can just say now the transformation on 1, 1 is the same as the transformation on 3x1 plus 2x2. And then we're going to use the properties of linear transformations. It's closed under addition, so you can actually split this into, the transformation on 3x1 plus the transformation on 2x2. Then since linear transformations are closed under multiplication, you can take out the constants here. So you can find that the transformation is actually equal to 3 times the transformation on x1 plus 2 times the transformation on x2. And then since x1 and x2 were established as eigenvectors of the transformation T, meaning that when you perform the transformation on those vectors will simply be scaled. And we already know the eigenvalues as well. Basically, the transformation on x1 is the same as 0x1, and the transformation on x2 is the same as 5x2. So you can substitute those into this, and we find that the transformation on 1, 1 is just equal to 3 times 0 times x1 plus 2 times 5 times x2. Since there's a 0 here, you just know that it's simply 10 x2, or 10 times its column matrix, which will make it the column matrix 20 and negative 40. Moving on to the next sub-item. Oof. Number 3, set up the product of 3 matrices to find a matrix A similar to the diagonal matrix below. So the first thing you should notice is the diagonal matrix used here, 0, 0, 0, 5. The diagonal elements are 0 and 5, which are exactly the respective eigenvalues of our vectors x1 and x2. So that's your hint that we're still going to be using the things that we found out in the previous items. So when you're doing diagonalization or finding similar matrices, because those are linked. When you're diagonalizing, you're finding a similar matrix. But in this case, we're already given the diagonalized matrix. What's going to happen is we just, so first, write out this equation so that you can see the bigger picture. So this is D. And then in this case, since C should be the matrix containing the eigenvectors corresponding to these eigenvalues, that's why we're able to just take our original vectors, because this is x1, remember? And this is x2. So since the eigenvalue of x1 is 0, or 0 is corresponded to x1, x1 is in the first column. Since 5 is corresponding to x2, x2 is in the second column. So next step to do here, since you just have this matrix inverse, solve for the actual matrix, solve for the actual inverse matrix. So when you solve for an inverse matrix, you just augment that matrix with the identity matrix. Because when you do an augment, the hidden question here is just what matrix do I need to multiply to the first one to get to the second one? So after you solve this, when you are able to make the left-hand side the identity matrix, the right-hand side should be the inverse matrix, which here is 2, 1, 3 halves, and 1 half. Then just um, substitute, or first of all, a step, hidden step over here. Let me add it in. You need to flip b equals c to negative 1 ac. You can change this to make it a equals something. So just make it a equals cd, c negative 1, and the ic inverse, and then just substitute or write out so that you have this one. Hurrah! And then next question is find a to the 4. And then conveniently again, we already have this a expressed in these terms, which if you remember, this is how we do diagonalization. So conveniently, they let us set up this final, basically the whole thing is a very long setup, but at least it's not multiple different items. And then, so a to the 4 is equal to just this, c times d to the 4 times c inverse. And then since it's d to the 4 and d is diagonal, you can just put the exponent here and here on the diagonal elements. And then, again, this is just brute work. Actually do the calculation. So this is the product of these two. And then you multiply these two. Ayan, expand until it's that. And that's it for number 4.
Um, just recall like what the four fundamental subspaces are. So that's the column space, null space, row space, and left null space. So TLDR, yung column space, I think Jerome mentioned this. This is all possible linear combinations of the matrix. So if you like, I guess deep theory wise, kasi in case lalabas siya sa final, because it is mulcho after all. It's basically the all the possible like spaces na a matrix like can occupy. I think I hope that makes sense. And the way you find that is apart from doing all the linear combinations, you also have to find a basis. And the basis is basically like the minimum amount of vectors that you need to span a space. And what that just means is like, let's say you have like, I don't know, it's easier to visualize kasi. Like if you have, let's say, a plane in 3D, right? Oh, oh my god. Okay. Tapos, obviously, for you to create a plane, you only need two vectors. Kasi you can like stretch one of the vectors and you can like squish one of it. And basically, you'll have like a collection of vectors. And all of that spans um, the 2D, the 2D object, the plane in 3D space. So basis is basically like having just these two vectors alone, you can use like an infinite number of linear combinations to map out the whole space. Okay, I hope that was clear. Pero that's basically what the basis is, and it's gonna be important later when we're looking for the answer now. Second is null space. It's basically just all the vectors that satisfy the multiplication. So this is a matrix, and then this is a vector, and then all vectors that satisfy this times zero um, will will be part of the null space. The way we find it, and it's vague here lang kasi di pa natin na-apply, pero just remember na we first change the matrix to reduce row echelon form. We'll find out na the system we have has non-unique solutions. Kasi syempre, a vector space is a collection of many vectors. So all those vectors are possible answers to ax equals 0. So you'll find out that it's non-unique. And then we want to solve for the variables in terms of each other. And then we can quote-unquote sort the variables. That's a bit vague, pero we'll demonstrate this later when we answer the problem. And then yung corresponding transpose ng nila is the row space and the left null space. A lot of these are like just basically the same definition lang, pero for the transpose, right? So yung row space, linear combinations ng A transpose. Yung left null space, all x that satisfies A transpose x equals 0. The most important thing though that you need to know is what they're orthogonal to. Kasi gagamitin yan as like, I guess, clues for questions. So the first is na, the row space is orthogonal to the null space. So parang quote-unquote baliktad siya. Kasi it's like, yung corresponding opposite na yung pinipair up. And then, similarly, yung left null space, orthogonal siya sa column space. And what it means for something to be orthogonal is that in that whole space, lahat ng vectors of a certain lahat ng vectors of a certain space is orthogonal. So that's an important property. So if you visualize it, right? If you have like, let's say the row space and the null space are both planes in R3. So pareho silang 2D figures in R3. Pwede kang magkaroon ng case na like, I don't know, it's like this. Excuse my terrible, you guys, line of two lang ako sa ES1, so forgive me. So, basically, you can imagine if they're both planes, all of the elements in the plane will intersect with one another. And that's what it basically means. Na if a certain vector space is orthogonal to another vector space, all of the constituent vectors in each space will be orthogonal or perpendicular to each other. I think perpendicular is like the 2D term, pero that's what it's effectively saying. It's orthogonal. Okay, sorry. Yap session over. Let's solve the problem. So let's first start by finding a basis for the null space of the matrix. And you might think, okay, so we're looking for the null space. Why are we looking for the column space? The reason for that is, apart from itatanong naman siya sa next item, so it's efficient solving. It's also the fact na we can use the rank nullity theorem, which is basically like the dimensions of the column space, which is equal to the rank. So this is equal to the dimensions of the column space plus the dimensions of the null space will be equal to the number of rows, or the number of rows. So what that means is na, because it's a bit more ambiguous to solve the null space, what we can do is solve for the column space first, figure out how many dimensions that is, and then use that information to solve for the null space. So let's do just that. So let's first solve the null space. The column space, sorry. Let's first solve the column space. And to do that, we will simply need to find a basis for the column space. And then, again, linear combinations na lang after that. So let's arbitrarily pick the leftmost column as our first vector. Kasi diba, the main takeaway from LE2 is that all of these are individual vectors. So it's just comparing if we can use them for the basis. And the way we can check if we can use them for the basis is if they're independent. So let's first start here. Arbitrary lang, pero it's also good practice na rin for di malito. So the first thing we want to check is this vector independent? I'll number them. Is vector 1 independent from vector 2? So to check that, there must be no C1 that exists. So when you multiply C1 to the vector, there should be no C1 that exists that can possibly quote unquote get you from the first vector to the second vector. So in this case, this is just a matter of visual inspection. Like if you think about it, kahit anong C1, sige, let's just do the solution language. For any C1 in R, so like whatever number lagay mo kay C1, um, this cannot be equal. Uh, wait, so yeah, this cannot be equal, and therefore the equality, like this equality can never be true, and therefore they are both independent. Kasi there's no way for you to reach the second vector by just multiplying the first. So that means that these two can make up the basis. So now we have two vectors that comprise the basis. And then let's just keep checking if vector 3 and 4 also comprise the basis, or are they dependent. Parang yun lang yung tinetest natin. So let's move on to the next. So negative 3, 0, 2, 1, C1 plus C2, 3, negative 3, 0, 3 equals. So now what we're testing is, can we get to the third vector, which is negative 9, 6, 2, and negative 5? Can we get to that by applying a certain linear combination of the previous two vectors? So this is in relation to what Jero mentioned kanina. This is like uh, like closure under addition. So you should not be able to add the previous two basis vectors in any way to get to the third. So let's do a bit of guesswork here. And just siguro let's like use some of our intuition. If you look at the second element here, 0 to. So no matter what C1 you put there, hindi siya makaka-affect sa 6 dito. What that tells us is the only number that can possibly get us to, quote unquote, get us to 6 is whatever you put in C2. So that means na it's probably a fair guess to try to find, like basically, quote unquote, ina-isolate natin siya. So magiging C2 times negative 3 equals 6. So obviously, that means na let's try C2 to be negative 2. So same thing here. We can also use the same line of logic here. Kasi 0 to, whatever value of C2 will not affect us, quote unquote, getting to 2, which is the third element sa vector na yan. So what that means is na C1 has all the effect towards quote unquote getting to this value. So we can also just do the same logic. C1 times 2 is equal to 2. So let's try C1 as 1. So now that we have siguro guess values for the 2, we can now see if tama yung hula natin. So this is just like, honestly, I think most of this item is really like educated guesses lang until you get it right. So anyway, adding both the vectors together. So 1 times negative 3, negative 3, 2, 3, negative 6. So combining negative 9. So good so far. 0, as we discussed, and this is 2 times negative 3. So that's, negative 2 times negative 3. So that's positive 6. 1 times 2 plus negative 2 times 0. So that's positive 2. 1 times 1 minus 2, negative 2 times 3. So that's 1 minus 1 plus negative 6. 1 minus 6, negative 5. So it is the same. So what this means is na we have successfully proven that the third vector is just a linear combination of the first two. And that therefore means na this vector, so theory portion of it, this vector is dependent on the first two. So therefore, not included sa basis. So this is not part of the basis. So we'll just repeat the same process for the fourth vector naman. I'll just speed this up a little para since we have a fair bit to go to pa. So I'll just like go through it. So same thing, hanap tayo ng hula for C1 and C2. This time we want to attempt to equate it to 6, -3, -2, -2. Um, in this case, my zeros ulit, so helpful. Let's guess positive 1 here kasi 1 times -3 is -3. In this case, let's guess -1 here kasi -1 times 2 is -2. So I think it's very likely na to be that. So anyway, 1 times -1 times -3 is 3 plus 1 times 3, so that's 6. So that's 0 plus -3. So that's 0 plus -3, and then that's -1 times 2 plus 1 times 0, so that's -2. And then that's -1 times 1, so -1 plus 1 times 3, so that's +2. Okay. So same thing happened. We were able to prove na similar lang sila. Right? We were able to get, quote unquote, get to the fourth, to vector 4 using the first two vectors. So ulit, it is dependent. So it is not included in the basis. So overall, what this means is that our column space is basically C1 times. So wait, I don't want to skip steps. So that means that the basis uh, is, well, not the basis of a basis, kasi a vector space can have different uh, combinations of bases. Pero the one we specifically found in this case is -3, 0, 2, and 1, and 3, -3, 0, 3. So that is the basis, is a basis for the column space. So I think this will show up sa next item. Pero theory-wise lang, this, we know na this is a 1, 2, two-dimensional figure, or two-dimensional object, right, or space. The way we know that is kasi we just check the amount of vectors. So there are two vectors. So it is a 2D figure in, count the number of rows, 1, 2, 3, 4 in 4D space. Or it is a plane, a two-dimensional object plane. So it's a plane in R4. This will show up later, pero all we need to know for now is na since the null space has sorry, since the null space has two dimensions, since the column space has two dimensions, the null space also has 4 minus 2 dimensions, or 2. So with that information, it'll be a bit more easy, I guess slightly less hard to figure out yung null space. So let's do that. So the first thing we'll do to find the null space is to do row operations. We want it to be in reduced row echelon form kasi it will make solving for the null space way easier. So in this case, so I do not screw up the arithmetic. I brought a guide. So the first thing I'll do, just to clean everything up, is R1 prime is equal to -1/3 R1, and R3 prime is equal to 3R3 plus 2R1. And then I'll also do R4, R4 prime is equal to 3R4 plus R1. So doing those three at the same time, it's okay naman to do that so it won't interfere with each other. That will give us 1, 0, 0, 0, -1 plus 3 minus 2, -3, 6, -3, 6, -12, 6, 0, 12, negative 24, 12. It looks a bit intimidating and messy now, pero it'll clean itself up. Once we do, R3 prime is equal to R3 plus 2R2. Kasi if you look, they're just multiples of each other, yung row 2, 3, and 4. So that gives us a very easy way to just cancel them all out. R4 prime is equal to R4 plus 4R2. When we perform that, what's going to happen is basically we're going to, so this becomes, this retains kasi it's the same. We didn't do any row operations there. This becomes 0, negative 3, same lang din because no row operations. Yung sa baba becomes 0 completely. And then the last, same with the last row. Yeah. So yan. Just for, I guess, easier solving down the line. Wait. I'll talk muna while it's doing that. Basically, what I'm gonna do next is just R2 prime is just 1/3 of row 2. So then, wait lang. What is happening? Why is it taking so long? Uh, Basically, what's going to happen, I'll just read out the whole row while we're waiting. It's just 1, negative 1, positive 3, negative 2. And then the second row will become 0, 1, negative 2, 1. And then nothing changes after. Um, the next step there is we will now want to do yung, wait, no. We will want to do yung, wait, technical difficulty. While we wait for that, the next thing you want to do is equate basically what you saw kanina to 0. So oh my god, right. So we equate the whole thing to 0, and then I'll just okay. I'll just raw dog it, guys. Sorry, I don't know what happened. Um, we'll equate the whole thing to 0, and then what we should get there is the variables are in terms of each other. So what that means is the answer that we'll get is actually puro siya variables until we clean it up. Uh, Wait, I will try ending screen share and then start it. I'm so sorry. Uh, I guess while we're waiting for me to figure this out, uh, just ask questions. Well, okay, I have figured it out. I think it was a storage problem. Sorry, guys. Can you guys see this? Let's just continue here.
Yep.
Is this visible?
Yes. Well, wala pang
Hello?
nakasulat, right? Hello?
Can someone confirm if this is visible now?
It is. Do you hear me here?
Hello?
Allah. Do you guys hear me? Technical
Hello?
difficulties are crazy.
In. Wait, somebody's.
Hello?
Okay, I'm gonna assume it is now. So I saw
Yep,
someone
yep.
react, but I can't hear anyone, just in case somebody is talking. So now that we found yung simplified matrix, which is well yung reduced row echelon form niya. So plus 3 minus 2. I'll just rewrite it. Now that we have that, um, we now want to fulfill yung condition which is ax equals 0. Uh, so that's basically what it looks like. So now, what we're going to do is um, try to, since alam natin two dimensions siya, we're targeting na there will be two vectors in the basis sa null space. So what that means is now our final answer will be in terms of two variables, and then we'll convert that to SNP. So the way we'll do that is, let's first just lay out what the matrix multiplication per row looks like. So this we can multiply to this, and then this we also multiply to this. So what that looks like is we have x1 minus x2 plus 3x3 minus 2x4 is equal to 0. And then we have x2 minus 2x2 plus, x3 plus x4 is equal to 0. So just to recap, it's this multiplied by this, and this multiplied by this. Okay, so ano lang siya, yeah, matrix multiplication. So now, what I'm gonna do is, uh, basically try to define, since we have x3 and x4 here, in the final answer, it's basically gonna look like this. So this is our um, half done null space, but we're trying to find out what those values are, right? So this is the null space already, but we want it to be in terms of maximum two variables. So since my x3, x4 dito, we can let that be. Let's try to define x1 and x2 in terms of other variables. So what that's gonna look like is we can let x2 be equal to 2x3 plus, minus x4. So transpose. So then, with this definition, we can plug that definition inside here. Um, so now this becomes 2x3 minus x4. That's the first part. The second thing that we can do is, since we have a definition for x2 in terms of x3 and x4, we can plug that into here. So yung mangyayari is, you have x1 minus 2x3 minus x4 plus 3x3 minus 2x4, that's equal to 0. So then, simplifying everything, this becomes x3. Yes, tama. And then this becomes negative x4. x1 plus x3 minus x4 equals 0. And that gives us x1 is equal to negative x3 plus x4. So now we can also plug this back in here. So yung x1 natin, we have a definition for it in terms of x3 and x4 na. Negative x3 plus x4. Now, the last thing we're gonna do is parang sort them, which is like what I showed sa slide kanina. Let's lump in all the x3 here, and then let's lump in all the x4 here. So now this is negative 1 kasi you have negative 1 x3. You have, actually wait, I'll show, I won't jump the steps. Okay, so this is now negative x3, 2x3, x3, 0, and this is x4, negative x4, 0, x4. If you quote unquote factor out the x3 and x4, and we can now let it be, I don't know, r s and uh, we can now let x3 be r, r, which is any real number, and x4 be s, which is also any real number. We can now factor them out. So lalabas na to. So now we have R, negative 1, 2, 1, 0, and S, 1, negative 1, 0, 1. So now that is the basis for your null space, which is what is being asked for. So your basis is now negative 1, 2, 1, 0, and 1, negative 1, 0, 1. So that is the final answer. Sige. Let me just check if I can access the slides. Okay. Still not. So I will try to access it so I can get the next question. So where were we? Ayan. So now, the next thing na pinapatanong sa atin is pinapa-describe yung column space and null space of the matrix. It's not clear here, pero it's basically asking us to describe it. So we described the first one na kanina, which is that it is yung column space is a plane in R4. And we got that by checking the amount of vectors and the amount of rows sa vector. So same thing here. So this is a 1, 2D. So it's a plane in R1, 2, 3, 4. So it is also a plane in R4. Which makes sense. Kasi ayun nga, nag-add up dapat yung column space and null space. Ayan. So this is basically the answer to number 2. We can also verify this again using rank nullity theorem. Kailangan yung rank, which is, I guess this is important in theory also, the dimension of the column space. Dapat, if you add it to the null space, the dimensions of the null space. So, this should be equal to n, or the amount of columns, or the amount of rows, sorry. So that is correct naman in our case. So this is good stuff. The next thing that's being asked for is is the column space and the null space of the matrix orthogonal components. This is more partially a theory question as well, kasi you just need to know which is orthogonal to which. So as we established kanina, yung null ay yung row space and null space, yun yung orthogonal. And then yung left null space and column space, yun yung orthogonal. So, I mean, honestly, this is really a theory question lang, disguised as a like solving question. So the answer there is just no, because it's not possible. It's not the, like, by definition they aren't. Pero you can also just multiply them together. Yung basis ng column space and yung basis ng null space, you can check manually by doing vector by doing vector multiplication, and you will get na they are not orthogonal, because when you multiply them together, you don't get the zero vector. So yeah, that's for the second to the last problem. The last one naman is there a vector orthogonal to both the row space and the left null space of A? Explain or share the solution. Here naman, it's again what the concept we used kanina, we can use it here again. This is actually a trick question. You don't have to solve for the left null space or the row space, because as we've established kanina, the column space, the column space is orthogonal to the left null space, and the null space is orthogonal to the row space. That means na instead of checking if a vector is perpendicular to both, so if a vector is perpendicular to the left null space and the row space, it has to be both in the column space and the null space. So effectively, an easier version of the question that gives us the same like literally gives us the same answer is find a vector that is in the column space and the null space. So I'll just rewrite the column space for everyone's convenience since nawalan tayo ng copy of it. So this is the column space. So this is a basis. Oh, wait. I'll write it na lang in terms of C1 and C2. In terms of like linear combinations, I mean. So this is C. We want yeah, okay. And then the null space naman, as we've established, is uh, just this. So I'll just copy paste. Okay. So now we want to find a vector that we can achieve using this, but we can also achieve using this. So kailangan pareho siyang, like we can find it in both the column space and the null space. So if you think about it, like visually, then, since these are both perpendicular planes, there is a line, and basically we're looking for that line that exists in both the perpendicular planes. That's what it's basically just saying. But anyway, uh, I guess one way you can approach this is you can, since alam natin na the vectors in the basis, the vectors that make up the basis are part of the space na. So let's say this singular vector, alam natin that's part of the column space and this singular vector. What we can do to make this solution easier is to just test it individually. So let's try to find a pair of a linear combination of the null space that yields this specific vector. So negative 3, 0, 2, and 1 equal r negative 1, 2, 1. Wait, 0. Wait, bakit siya? Sorry, that's naduling ako. Yeah, negative plus s 1, negative 1, 0, 1. Okay, so now what we'll do is look for a specific combination. I think in this case, let's try r equals 2 kasi to make this, to achieve this. And then s equals, kasi if this is s equals negative 2, if this is s equals 2, to make this 0. Okay, so parang, again, trial and error, hindi siya feasible because we will just end up with a very complicated value for r and s. What we can try instead, since again, di naman just the first vector lang, we can also just try the second vector, which will also yield, let's see if this is better and finding a simpler negative 1, 2, 1, 0 plus is 1, negative 1, 0. So what we can try here is we could try setting r equals 0 para makuha natin, para ma-0 siya. And then, since, right, kasi third element to. So we want r to be 0 para ma-0 to 1. And then, s can be any number. So let's figure out what s can be. Let's try s as 3, right? Para mag-match yung etong 3. Since this is 0 already, let's make this 3 by having s equals 3. Doing that, 3, 1, negative 1, 0, 1. And then we get na this is just 3, negative 3, 0, 3, which is equal to the first number, yung the vector kanina. So what this means is na, remember, this is a basis of the column space. So it is in the column space. So this is in the column space. And we figured out now when r is 0 and s is 3, this vector is also a linear combination of the null space. So in terms of our final answer, the answer is yes. Uh, we have proven by example that there exists that this vector is in the null space, in the null space. Oh yeah, and the column space, and therefore it is orthogonal. Sorry, orthogonal to both uh, the row space and the left null space. That's basically the full solution for this item. Um, I hope that's clear. Uh, I'll try to be more concise next time so we stay on time. But yeah, I think this is a particularly tricky question. So I hope that was clear. Sana gets niyo rin yung na-integrate natin na theory along the way. So that's for um that's for problem 2. I don't remember problem 3, so I'll try to access it again. Okay, it's not working. So I just keep going. So I'll just rewrite the question. I have it here. So for problem, you're basically tasked to find a series of linear transformations denoted as A1 and A2 that convert this specific, so that perform this specific function. So x squared ax squared y plus by by plus cx plus b. So it takes the partial derivative of that with respect to x, and then inside that you take the partial derivative. Ay, wait. Tama. Yes, that's correct. Partial derivative of that with respect to x, and then partial derivative of that with respect to y. Okay, so now what we want to do is figure out the overall linear transformation, which is comprised of two matrices. So the way we approach this problem is first, we want to first visualize just what this actual function is. So this is a partial series like of partial derivatives stuff. So like math 23 stuff. So let's just first see it in action. So let's line up all the terms now. So this is the original. And while we're at it, we can actually by plus cx plus b. And then what we can do is differentiate it with respect to x first. So magiging 2axy. So at this point, we're not doing anything like technical pa. We just want to see what it looks like. And then 2ax plus 0 plus 0 plus 0. So now, what we can do is arbitrarily assign na these will be vectors. So these will end up as vectors. So now, given the basis are like the dimensions of every single vector are arbitrary, let's just do it in terms of the intern number. So this is first one, second one, third one, fourth one. And let's make that consistent throughout. So what that means is na, once you take out x and y, kasi they're not really coefficients, right? So we can make them like the dimensions of the vectors. This will make more sense in a bit. So basically, yung mangyari is you start with this, and then we can just label them sa gilid. Again, these don't have any bearings na. So now, because this is A1, A2,
the first transformation will be A2 kasi right to left siya, diba? So, meaning we have A2 here times this, yung lalabas daw is this, what we just solved. So this is 2A, 0, so 0, um, C, 0. So now this is XY. Then we don't really have to mind na nagbago na siya. That's just normal constants. Especially kasi we're differentiating, guys. So now, what we can do is equate these two together. So now what you'll end up with is this. Okay. Um, so now it's just a matter of matrix multiplication. Let's try to figure out what to put in each box. So let's first start by multiplying this row. This column to this row. So the top row. Um, yung result daw niyan is 2A. So let's figure out what creates 2A. So we want A to be doubled. And then we want B, C, and D to not show up. So kailangan natin siya 0. So ayan, that's the first row. For the second row, we want it to be completely 0. So it's just that kasi none of the um, factors are the same. For C naman, we want C to show up. So we just want the third element, uh, isipin natin saan dito yung 1 kasi it's somewhere here. Pero where? If you look at how it's multiplied, this is multiplied here, this is multiplied here, this is multiplied here, this is multiplied here to get the product. So that means na C must be multiplied by whatever is here to get C. So that means na dyan yung 1 and then everywhere else is 0. And then same thing sa D. We don't want it to show up, so it disappears. Pwede rin completely baliktad siya. So nasa bottom corner yung 2. Arbitrary naman kasi yung pag-order natin na ito yung top ng matrix, ito yung bottom. The point is na we label it properly and we represent it, which is what we're doing naman. So that means now we're good na for the first part. So this is already A2. That's the first transformation. Next naman, we just basically apply this to the bottom. Ito naman yung ita-transform natin ulit. Kasi, di ba, if you visualize it, A1, A2, this is your starting vector. And then, this is the end. This is the ending. So this multiplied by this becomes one vector, which is what we saw here. So now this is the first one, the second one. And then just multiply it by the second transformation. So now, same thing. Hanapin natin yung matrix that corresponds to the linear transformation we're looking for. So now we want it to be like this yung sa dulo. So this is now 2A x and then 0, 0, 0. So all constants. In this case, we want 2A to stay 2A. So again, visualizing where each element multiplies, this here, respectively. So that means that 1 has to be here. Para pag multiply mo, it's 2A times 1 to get 2A. So that means na the rest are 0. And since the rest of the vector products are 0, it really doesn't matter. Pero you want a 0 lang na lang for the sake of simplicity. So ayan. That's our final answer. So these are the two matrix transformations. So let's just test it on yung requirement kasi ng question is we test it. So let's just test it. Let's just assign, for the sake of simplicity, let's just assign A, B, C, and D to be all equal to 1. That's not a problem naman. And then let's line up yung matrices natin. So yeah, it's just Um, okay, there. And then, so basically, based on our how we define the dimensions ng matrix, same thing lang. So that's 1, 1, 1, 1. So let's first just multiply this. So this becomes 2, 0, 1, 0. Um, and then same thing here. Same thing here. Now this becomes 2, 0, 0, 0. So, which makes sense kasi if you differentiate this, if you differentiate x squared y plus y plus x plus 1, if you differentiate it with respect to x, magiging 2xy plus 0 plus 1 plus 0. So it lines up 2, 0, 1, 0, 2, 0, 1, 0. And then if you differentiate it with respect to y, it becomes 2x, 0 plus 0 plus 0, 2, 0, 0, 0. So ayan, that's basically for number 3. It's not really like a hard computational problem. It's really just make sure you know your fundamentals sa uh treating matrices as functions that transform an input to an output. That's what basically is being tested in this specific part. So that's it for unit 2. So let's move on to unit 3. Pero Jerome, do you mind doing problem 2 first? Kasi I was supposed to do problem 1, Jerome problem 2. Pero I'll try to fix my slides muna if it will work. So can you
It's
do
fine with me.
problem 2 muna?
Okay. Let me just share my screen.
Wait, sorry.
Oh,
I,
yes.
I hear you now. Okay,
Okay.
you're Gina. Man.
Yes, G.
Okay, thank you.
So I'll take a breather lang first. Mga 1 minute. One minute is done. Welcome back, everyone. So, start with problem 2 ng LE3. Hindi siya labeled that much here, but it's this number 3. You remember? Basically, yung word problem sa LE3. So, concept lang. Wala masyadong concept since it's application na. And then, this item is just a specific kind of application, volume. Usually, pag volume, the one that they make us apply or the method we use there is yung folde or folde. Mostly folde. I'm not sure if my example na folde. Okay, so let's just get right into it. So our setup is a tank is at 50% capacity with 900 gallons of water and 1 ounce of pollution. So that's our initial conditions. And then so 20 gallons of clean water with 23 over 90 ounces per gallon of pollution are added to the tank per hour. Medyo iffy yung phrasing there, but I think it's if you remember the question. Simultaneously, 10 gallons of the uniformly mixed tank contents are drained per hour. So first sub-question is, how long does it take before the tank overflows? So usually pagdating sa volume questions, the easiest one is that kind of question yung sa number one. Yun yung easy part. The how long does it take before the tank overflows? Because it's a question about the overall volume inside the tank. Oh, chat. Okay. Anyway, so since it's about the overall volume, usually the here. Oh, we start first by writing out our dV over dt. So that's the rate of change of the volume. And then why I'm saying is it's usually easier. The easier part is so yung given here, 20 gallons of water are added to the tank per hour. Then 10 gallons of the mixture are drained per hour. So for us when we're solving dV over dt, that just means it's 20, the inflow, minus 10, the outflow. Ito yung easy part because you don't have to care much about the concentration of the mixture when you're doing just the overall volume. So from here, you can transfer yung dt to the other side. It's going to be dv equals 10 dt. You just integrate both sides to get volume v as a function of t. But then you have this plus c1. That's when you use your initial conditions to clear out yung integration constant. So t equals 0, we know that the volume starts at 900 gallons. So if you substitute zero here, you'll find that C1 is equal to 900. So our full function of the volume as a function of time is V equals 10T plus 900. And then if you want to just ask, how much does it take before the tank overflows? We know na overflow, first you need to find the maximum volume. I wrote it here na. Sorry, super spoiler yung style ko, but sana you're able to follow. They told us na it's at 50% capacity at 900 gallons. And what's 100% capacity? 900 times 2, 1,800. So just equate 1,800 to 10t plus 900 to find the time at which volume will be 1,800. And then if you just solve that, you'll find that the tank will be full at t equals 90 hours. So tapos na yung easy part. Going on to the next part. So since we were solving for dv over dt, now let's solve for dp over dt, or the rate of change of the amount of pollution in the tank. So first, let's start with the inflow. So we know that the inflow is, let's add the dimensions here. So we know na 20 gallons per hour are coming in, and then the concentration of those 20 gallons is 23 ounces. 23 over 90 ounces per gallon. So if you just do dimensional analysis, cross that out, you change it to ounces per hour, which is what you want, because it's rate of change of the pollution, which is measured in ounces. And then there's also an outflow, but we can't say for sure how much is being outflowed, what the rate of outflow is, because it's also not constant. Excuse me. Because it depends on the concentration of the pollution in the in the tank. So what we can do is just say na since 10 gallons per hour yung outflow, you multiply it, you multiply those 10 gallons. I can hold on. 10 gallons per hour times the concentration. Since this is P, this is ounces. This is gallons because this is the volume. So cross that out. Ounces per hour din siya. So when we have this, you're not yet done because we have this V. And if we have two different what do you call it? Independent or dependent variables, we can't really do anything. Or basically you consider V an unknown, or it's we have to substitute it with the function of V as a function with V as a function of time. Yeah. So that's what we're going to do here. 20 gallons times 20 over 90. And then this P over V became P over 10t plus 900. Because if you remember, function of V as V as a function of time is 10t plus 900. So that's just what we did here. We replaced the V with the function. Oops, accidentally took a screenshot. Anyway, so you can simplify some of this stuff. So multiply this now, 4060 over 90. Then cancel out the 10. So it becomes 1 over t plus 90. And then from here na, you can change this into folder form. So just transfer the term that has a p in it, since if you check folder form, it should be dy over dx plus y. And in this case, this is the dependent variable. Our dependent variable is p. So p is our y. And sorry, medyo confusing na yung sa formula is also a p of x. So basically, if we change it to folder form, it's this dp over dt plus 1 over t plus 90 times p equals 46 over 9. And then our p of t, and this isn't p as in pollution, this is p yung sa folder form, is 1 over t plus 90. And then our q is 46 over 9. And then we know that our integrating factor is going to be e to the integral of p of x, or in this case, p of t. This is just formula. Plug in, memorize that, because walang formula sheet. So that's e to the ln t plus 90, because integral of 1 over t plus 90 is ln t plus 90. And then since it's a logarithm, Euler's number raised to a natural logarithm, tama ba yun? Basta, e raised to ln, ayan, sorry, ang dami kong ebas. E raised to ln, you can just take the inside of this and then put it out. T plus 90 is the integrating factor. So following again the formula, this you'll get p times t plus 90 equals the integral of t plus 90 times 46 over 9 plus c, and you solve it and choo-choo, then you'll get this. To clear out the integrating constant, you use again your initial conditions. At t equals 0, there's only 1 ounce of pollution. So then if you substitute 0 into t and 1 into p, you'll get that C1 is equal to 90. So, asan yung sinulat ko? Okay, I didn't write it. So basically, you have this p t plus 90 equals 46 over 9 t squared over 2 plus 90t plus C1. Sorry, not C1. We know what C1 is already. 90. Okay. So now, the original question is, how much pollution in the tank at the time of overflow? We know that the time of overflow is t equals 90. So we just substitute 90 into t and then algebra it to get the answer. I think you guys can do algebra, so I didn't put the whole solution there. The answer is just going to be 691 over 2 ounces. Whew. Um, in our exam, my points for like fully phrasing the answer, pero mulcha naman yung final niya. So, it's okay. Don't worry about that. Don't you worry, child. Okay, so part B of problem 2, LE3. When overflow starts, inflow is stopped and outflow is reduced to 5 gallons per hour. How long after inflow is stopped does it take for the tank to reach 25% capacity? How much pollution is in the tank at the time of 25% capacity? So the first thing of this sub-question signals us that we can reset our T. We can set a new T equals 0. So our new initial conditions for part B, T equals 0. P is equal to 691 over 2, because this is what we got from the last problem. We know now when it starts overflowing, it's going to start with 691 over 2 ounces of pollution. And when it starts overflowing, the volume is going to be at max 1,800. Right. Inflow is stopped and outflow is reduced to 5. So this is just 0 minus 5, which makes it negative 5. Wow. Anyway, can do the same thing. Basically, itong part B, it's the same as part A with different conditions. So you can do the same thing we did. You'll get the the function of v as a function of t, negative 5t plus 1,800. I didn't write it. T equals negative 5t plus 1,800. And then to find out when it reaches 25% capacity, which is just 1,800 over 4. You equate 1,800 over 4 to our function to get to solve for t, which you'll find na it will be 25% capacity after 270 hours of stopped inflow. And then again, that's the easy part. Um, Moving on to the next subparts. How much pollution is in the tank at the time of 25% capacity? So same procedure, dp over dt, wala nang inflow again. So it's just -5 times the concentration of pollution in the entire tank, which is the P over V. Yeah. So again, we're going to replace V with V as a function of time. So it's going to become -5 times P over -5T plus 1,800. And just to add, like in some, I remember there was an example item before na the V is constant. So in that case, that's when you can just replace V with a certain number. Otherwise, if you know na V is not going to be constant over time, you should expect na this will not be a constant. It should be a function of time. Yun na. Anyway, so just simplify, cancel out the 5. dp over dt equals -p over 360 minus t. You can transfer it over to the other side. Then you'll get another folded form where this time q of x is 0, and then the folded p of x is 1 over 360 minus t. And then you do the same thing because you're going to get that p times 1 over 360 minus t is equal to c1. You want to clear that c1 since it's unknown. Use your initial conditions. T equals 0. P is 691 over 2. So just substitute 0 here. Then you'll get na c1 is equal to 691 over 720. So to find if you want to solve for p at any time t, just put in t into this, p times 1 over 360 minus t equals 691 over 720. So at time 270 hours, which is the time of 25% capacity, which is being asked for here, you can plug it in and then you solve it. You should get 691 over 8 ounces. Whew. And then part C, yeah, set up lang siya. But if you were to follow through with the solving, if you were given the actual W, it's just the same, so wait, same procedure. So suppose alpha remains the same, but clean water is added at a rate of W, where 0 is less than W is less than 5 gallons per minute. Set up the equation in full the form that would represent the change in pollution over time. So I think yung 0 to 5 is just to clarify na may net outflow pa rin. But in the end, honestly, we didn't need to know that it's 0 to 5, but they just wanted to tell you. Um, so the change in volume over time is just this W, our new outflow, our new inflow, sorry, of clean water, minus 5, our outflow from part B, which is the same. Okay. Integrate both sides again just to get na Wt minus 5t plus C1 is the function of V in time. And then clear the C1 with initial conditions. T equals 0, V equals 1,800. So V as a function of time is Wt minus 5t plus 1,800. And then same thing here, dp over dt equals -5 times the concentration of pollution. And then replace the V with V as a function of time. dp over dt equals -5 times p over wt minus 5t plus 1,800. Transfer it over. Oops, I forgot to put the p. Just transfer it over. You can maintain full deform if you wanna. Ay, mucho naman pala. But yeah, I maintain full deform here to make it clear that this is already in full deform. That's it for problem. Problem 2 of LE3. Let me check chat now. Oh, sorry, I missed the question. Jerome, for 5t plus C1, is that a general formula? Like it will always be V equals inflow minus outflow plus C1. Okay, hold on. Asan yung 5D plus C1? Ito. Yes, usually sa given kasi when they tell you volume, since this is the volume of the overall, it's just gonna be flat numbers, inflow minus outflow, and then since this is a rate, this is dV over dt. The secret step here, is just, well, not so secret, sinabi ko rin naman. dV is equal to -5 dt. You integrate both sides, so it's gonna be v equals -5t. And then, when you integrate, there's an integration constant. So plus C1. So, I mean, it's dangerous to say always, that it's always going to be like this. But from the examples they give us, pag overall volume, it's usually like this lang. Inflow minus outflow plus C1, and then usually then C1 is the initial volume. But it will always depend on the context if they come up with some twisted problem where this is not the case. But usually it is. You know. You ready, Hugh? Are you ready for
Yep.
this?
Let us finish this off. Pero I'll answer like a few PMs muna before I go. So before I move on to the next problem. So this is like from Elite pa. Sorry, I only just saw it now because I was trying to fix the issue. So what is the difference between dimension CA and dimension NA? Like how do we solve for them individually? Basically, you can solve for them individually by using your basis. So the number of bases that you have will determine the dimension of the space. So if I have three vectors that create the column space, uh, then I have like the dimension of my column space is 3. Ganun lang siya. And then same thing with the dimension of the null space. It's all dependent on the number of vectors you have. So ayun nga, as we discussed sa problem 2, part 2, it is number of vectors, dimension object in Rn, where n is the number of rows or the number of parang elements in the vector. So if it's like 4, it's R4. Ganun. So that's for that first question. The second question is yung sa previous solution, so turning it in terms of R3 and 4. I will start sharing my screen na to visualize this. So I believe this is this part. Ayan, ito. So the reason why we did this is, I mean, technically we could do this with x1 and x2 and everything else. But the reason why we chose x3 and x4 is they are present in all three, in both the equations. So it's easier to work with them. I guess hypothetically, pwede namang x2 and x3 or x2 and x4. That's also fine. The idea lang is you want to end up with only two variables because you know that your null space has two dimensions from yung rank nullity theorem. And then we figured out na the column space has two dimensions. So by that logic, kailangan the null space also has two dimensions. So we wanted it to be isolated in terms of two variables. So ayun lang. Basically, the arbitrary part is choosing x3 and x4. It could have used x2 instead, and then whatever na lang yung ano. And then yung magbabago is x3 and x4. Pero the idea is, the non-arbitrary part is, we want it to be in terms of two variables. I just chose x3 and x4 kasi they were, I guess, the easiest to explain. Kasi when you plug in, like, di ba, we got the definition for x2 here. When you plug it in dito, it's also the least complicated. Kasi ayaw mo namang mag-multiply pa by 3 or mag-multiply pa by -2. Error prone yan. So might as well do x2 kasi it's pretty simple then sa first equation. So that's the thought process for that. I hope that was clear sa nagtanong. And I guess for everyone then who was wondering. So yeah, we have 30 minutes left. So let's go to problem 1 ng LE3. So these are some of the things you need to know. Again, we will send this out, so no worries. Pero take a screenshot if you still prefer to do that. So just basic theory ng DEs, all the solving methods, applications, which Jerome just went over, and then systems. So let's first start by doing this problem 1A, yung first part ng problem 1. So just the most appropriate method for solving the following DEs. If you see here, naglagay ako ng none. That's a spoiler for one of the later items. Pero yeah, consider na lang na none of the above is a typical option na linalagay sa mga test. So that will probably show up na scenario. So let's get started sa first one. So this is already laid out in this format. I believe this should be equals tama ba or equals 0. Wait, let me double check. Tama, equals 0 dapat. So then this is minus. That's our bad. Okay, so now what we want to do is first change it to general form. So general form means that it's mdx plus ndy equals 0. So yeah. So now standard general form pala to. Yeah. Standard form yung for full diff of the. So this is general form, and then so let's just do that. Let's distribute the negative na. So this negative ln y plus 2xy plus 5x dx plus x over y minus y squared plus x squared dy equals 0. So let's first evaluate if kaya siyang i-varcep. Usually sa varcep, if there are any factors na gusto mong ilabas na di siya of that variable, they usually have to be the same power, and that's your hint. There's no one factor you can do to bring out the y in ln y and y here. Kasi if you divide all of this by ln y, mawawala yung ln y, pero magkakaroon ka ng 2xy over ln y. Same thing is true if you do y here. And the same thing is true even if you do like y ln y. It still will not cancel. So because they are of varying power, especially kasi it's ln, we know na it's not varcep. So yeah, acceptable solution naman ata yung to explain it in word form, but you guys won't have to worry about that. So basta this is not varcep, as we've proven. So let's not test if it's exact. So this, para di kayo malito sa exact, it's the term with x yung i-differentiate mo with respect to y, and it's the term with y yung i-differentiate mo with respect to x. This is analogous to yung potential function in Math 23, in case you guys are more comfortable with that concept. It has the same, like the mathematics behind it is the same. So anyway, this becomes negative 1 over y plus 2x plus no, joke lang. Test lang yun, guys. 0 pala. Sorry. And then this becomes negative 1 over y kasi okay, my bad. I did it this way. May negative pala dapat sa given. May negative pala dapat yung given. Sorry. Negative 1 over y plus 2x plus 0. So because they are equal, we can conclude na exact method is allowed. So yan lang. Sinabi namang no need to solve. So that's basically the solution for 1A. For 1B naman, for 1B naman, this is slightly complicated. And to be fair to them, it's quite a well-written question. Like, if you make a small mistake, you might think it's one of the other forms, which is what almost happened to me. So, yeah, well-written question. So let's just do the usual procedure. So this is, let's turn it into general form first before we change it to standard form. So general form is the one for exact and varset, and then standard form is the one for folde-fobde. So what we're gonna do here is transpose. So maging negative yung whole term. But what I'm gonna do is distribute the whole negative term na. So it becomes negative 8xy squared minus 4x squared minus 4x dy equals 0. Yan. So, let's first test if it's varset. Again, using the same logic data. So think about this as, syempre this is y to the negative 1, and you have y to the positive 1. So again, we run into the same problem na we can't factor it out kasi if we divide this by y, magiging y squared siya dito. If we divide this y, if we divide this by y, if we multiply the whole, yeah, if we multiply the whole term by y, yung mangyayari naman is maka-cancel to, pero magiging y squared to. So, same logic, different powers yung kailangan mong i-factor out. So, varset cannot work. So, rule out na natin si varset. So now let's try exact. Let's do the same thing as sa taas. So, again, the term with dx, we will differentiate this with respect to y. And then the term with dy, we will differentiate this with respect to x. So, okay, let's go. So this is 2x, this is 2x. This is 0. And then this is negative x over y squared. Yan. Dx. Yung kabila naman is equal to, so dx nito is negative 8y squared. So already, you can see na it's like, it's negative 8x. You can already see na it's veering off significantly. It's 8y squared minus 8x minus 4. Diyan, layo. So it's not exact. Next that we'll try, so syempre we don't try Shode kasi it's a first order lang. Shode is for higher order na reducible. So we will now test folde-fobde. So we will now convert it to standard form, which is done by isolating dx and dx over dy to one side. So let's first try dx over dy. So let's test if it is linear in y. Linear in, when you say something is linear in x or y, usually check the bottom. So if it's linear in y, it's linear in yung baba is dy. Sorry. Yan. So just adding this all together is 4x over 2xy plus x squared plus x over y. Just in case that was a bit confusing, yung ginawa ko lang is, I brought this down sa kabila. And then I brought this down. And then I brought this down dito. So, this napunta siya sa denominator. This napunta sa denominator. So, I hope that made sense. Basically, yun ang ginawa ko. So, nothing like overly complicated. We can try simplifying this further just to see if it will bring out the form that we want. So, dx over dy. Let's try to separate it by term. So let's break up the numerator. So this will become 8xy squared, 2xy plus x squared plus x over y. I guess we can cancel out x here. So now it's 8y squared over 2y plus x plus xy. We will run into the same problem here na let's factor out x here na rin. So 2y plus x plus 1 over y plus 4. Okay, so at this point, it's fairly obvious na it's very difficult to bring this out in FOLDE or FOBDE form kasi you can test them at the same time because they have similar forms. Kasi if you check the form, it's it require like yung px kineme, it does not line up even if you factor in kasi may x dito and they're added, they're not multiplied. So ibig sabihin, we can't bring it out to be in FOLDE or FOBDE form. At least it's not linear in y. We can try doing the same procedure, dy over dx, and then i-flip natin yung numerator at denominator. Yeah, I guess we could try that. Pero if effectively, I think you guys, most people, as most people have realized sa exam, this does not eventually add up to to the correct form. So yeah, pati ito, this does not end up. So basically, hindi siya FOLDE or FOBDE. Yeah, even if you guys try simplifying this, it will not come up to that figure. So it's not FOLDE or FOBDE. The last thing we'll try is integrating factor. So there are a few ways to, there are three variants of integrating factor. Una, if it's completely in terms of x or completely in terms of y. So, if you guys recall, nag-try tayo ng exact method. This is partial of m over partial of y. And then this is partial of n over partial of x. We can actually just use that kasi ito rin yung lalabas sa testing for integrating factor. So when we test the test if it's an integrated factor, we run into the same issue. So xy squared plus 4x squared plus 4x kasi the form is 1 over m, 1 over n times 1 over n times m partial of m with respect to y minus partial of n with respect to x. So this is we're testing if it is a function of x alone. So just writing that out down. This will run into the same problem. Hindi mo siya makakancel. So it's just from this part alone, it's fair enough to conclude na you cannot bring it out to be a function of x alone. So you can just leave it at that. Hindi siya lalabas to x only. You can try the same for y. Same thing then, the arithmetic is gonna take so long, and I feel like we should discuss concepts na lang as opposed to just you looking at me trying to not fumble arithmetic. So the setup is like this. So it's similar lang, except now we're looking at negative 1m. And it will yield the same answer na hindi siya in terms of y. So the mistake I made here is I ended the logic there. I was like, no other forms are possible. Therefore, it should be integrating factor in terms of x and y. Supposedly daw, yung real answer is that there is no method, there is no appropriate method to solve this. And the way you'll show that lang is by basically taking yung equation for if in both x and y, plugging it all in, and demonstrating that you cannot get a value, you cannot find small m and small n that will give you that value. So uh, basically, if you try x and y, you cannot find, or you should not be able to find uh, an m and n. So therefore, yung final answer is there is no method, which is really weird because you're asking for which method. Malamang like we will try all the methods. Weird phrasing lang ng question ng department. So anyway, let us now move on to a more, I guess, actual thinking problem rather than just plug and play. So let's move on to 1B. Given tayo ng incomplete MVP setup, and our goal is to sorry, find the original DE and the complete solution. So the first thing now we want to do is, even though it's asking for the original DE, the first step talaga is to just complete the table. So what do we know sa MVP setup? Like, how does it work? Diba, we know na the first thing we know is that pababa, you're just differentiating again and again. So what this implies is na whatever is below this is just a derivative of these two, and whatever is above is just an integral of these two. So an integral with I guess c equals 0, like constant is 0. So let's first do that part. This is a lot of just manual stuff, so I will try to just get it done with agad. So this is, so if you take the derivative of this just becomes x e to the x, and then taking the derivative of this, so you get left d right plus right d left plus integral neto. So you just end up with x ex plus 2ex. And just verify. Yeah. Okay. So that's what basically happens here. Differentiate, integrate lang. And then dito naman, it's just a matter, same thing. So if you differentiate this, you will just use chain rule. So 2 is constant, e to the 2x, and then because my 2x, the derivative of 2x is 2, so it just becomes 4ex. 4e to the x. And same thing here, mag-integrate ka. I guess since, okay, let's just show it. So integral 2e to the 2x. So what you'll do here is just like let u equals to x, and then du is equal to 2 dx 2 dx. So magka-cancel yan, magiging e to the u du. So you get e to the u, and then plug it back in, u equals 2x. So this becomes e to the 2x all over again. Okay, so malapit na tayo. Pero what is the first row? What is the first column? Let's think about this. Let's think about this by figuring out what the main solution is. So, if you think about it, diba? Yung structure ng repeated roots is as follows. You have C1, e to the x, and then you have C2, x e to the x, and then you have C3, e to the 2x. So what this implies is na the first column must be e to the x, kasi that's the only way you will have x e to the x, which like it has to imply na may repeating na nangyari. Because that's the only way you'll get x e to the x as a starting number dito sa taas. So that suggests na this whole column, this whole column is just e to the x. So now that we've figured that out, um, what we want to do is reverse engineer YC, which is what we've kind of already did, right? Kasi yung full solution is y equals yc plus yp. We figured out na for us to have e to the x, this must have been, so yc must have been, uh, sorry, yc must have been, e to the x plus c1 e to the x, and then c2 x e to the x, and then c3 e to the 2x. So that's yc. Now, since we figured out the table and we figured out yc, what we can do next is basically solve for the original DE. And the way we can do that is by figuring out the roots. So from here, di ba yung format ng YC is whichever yung nasa taas, coefficient niya ng roots. So what this suggests to us is now we have 1, yung roots natin is 1, 1, and 2. So we have roots 1, 1, and 2. So that suggests to us na yung auxiliary equation natin, so we're working backwards, right? Kasi usually, diba, we start with the original DE, then we make it into an auxiliary function, and then we make it into YC. What we're doing is the reverse. So now we have the roots. Now we know na it is m minus 1, m minus 1, m minus 2. So now we know that this is the auxiliary equation. So now, what we want to do is just expand that fully so that we can get the actual equation. So this is just a matter of, algebra. So I'll just show it in full here. So this is just multiplying these together, you get this. This is just my preferred way of doing it para di siya nakakalito. Pero effectively, you get this. And then we can just lay it out. So m cubed minus 4m squared plus 5m plus 2. So now, we can convert the m back into d, or in this case, so you have d cubed minus 4d squared plus 5d, minus 2. Minus 2 pala, sorry. All multiplied by y equals what? Going back to the table, nakita natin na 2 yung coefficient dito, and that's the coefficient of the right hand side, or that's the number on the right hand side, 2. So that's the almost final answer. Then we just have to remember na d is equal to d cubed y over dx. D is dy over dx. So d raised to 3 is d cubed y over dx. Sorry, d cubed over dx lang, kasi y is here. So multiplying y across the whole thing. So magiging 4d squared y over dx squared plus 5 dy over dx minus 2y equal to 2. So yun yung original DE. So that's the first thing asked from us, to find the original differential equation. So now, let's continue and find the complete solution. So solving for yp now, we have this table. I'll just, okay, sige. So, now we solve using MVP. So, what we're gonna do to make this convenient, since mag-Kramer's rule tayo, I'm gonna first convert this into a reduced row echelon form ulit. Kasi, since the Kramer's rule requires us to find the determinant, it's just easier if the determinant is the diagonal ulit. So, let's just do some, uh, row operations natin siya. So, it's easier to work with. So, I will do R2 prime equals R2 minus R1. I want to get rid of this. And then I want to get rid of this. I want to get rid of these two. Sorry. I want to get rid of these two. So R3 prime is equal to R3 minus R1. This will end up being both very convenient kasi what will then happen is you have e to the x x e to the x, and then e to the 2x, and then you have e to the x, this will be e to the x na lang, and this will be 2e, this will be e to the 2x na lang. Kasi 2e to the 2x minus e to the 2x. And then same thing here. Oh, sorry, naduling ako. 0 na dapat yung both na yan. Magma-minus lang siya. So you are left, so it's this minus this, you are left with e to the x. You are left with, you're left with e to the x. And then you are left with, you are left with 2e to the x. And then you are left with 2e to x, 3e to x. Okay. So now, just to finish this off further, we want to remove this. So R3 prime is equal to R3 minus 2R2. So that becomes e to the x, e to the x, e to the 2x, 0, e to the x, e to the 2x, 0, 0, and then this becomes e to the 2x. So now that is our final. This is our final matrix na, and we can tell na the determinant of this, let's just name it matrix A, is equal to e to the 4x, and we can use that later when we're executing Kramer's rule. So I will just quickly bring that down. Solve tayo for yp. Okay, so now let's use Kramer's rule to solve for yp. What we're basically just gonna do, kasi bringing back the original equation, this is just times u1 prime, u2 prime, u3 prime equals this whole thing. So now what we're gonna do is basically we're just gonna multiply. So we wanna now equate all these three to this. So i-Kramer's rule lang natin. And basically we put in the, so this, imagine this is the original matrix. U1, U2, U3, 0, 0, 2. So we're just gonna integrate the matrix there. We're just gonna integrate this into here for the corresponding rows to get the specific determinants, right? Kasi it's just a quotient of determinants yung Kramer's rule. So doing that, let's first start with row 1. This is just equal to 0, 0, 2, and then I'll just write down yung original na equation. Okay, slightly different siya, pero I just basically grouped them together, yung mga e to the x. So this is now x plus 1 e to the x, and then this is x plus 2 e to the x. But I didn't change anything naman, just so it's easier to work with. And then x plus 2 e to the x. And then same thing lang yung dito, e to the 2x, 2e to the 2x, 4e to the 2x. So then I solved for the determinant of this. You will get x minus 1 e to the 3x. So that's a1. But again, you have to divide this by the determinant. So the determinant of a, which we got kanina, which is basically e to the 4x. So your final equation, so u1 prime is equal to 2x minus 1 over e to the x. Repeating this similar process, just for the interest of time, repeating the similar process, sige, I'll show some of it na rin. A2. But you just have to repeat this process 3 times. So e to the x, e to the x, e to the x. 0, 0, 2, e to the 2x, 2e to the 2x, and then 4e to the 2x. Right? For me, I used cofactor method because we can use 2 here. The zeros yung iba. So nagka-cancel lang siya. And then we basically get 2 times negative 1 is the third row and the second column. And then the determinant of e to the x, 2e, 2x. Getting the determinant of this, kasi nag-cofactor lang ako, I will effectively get negative 2, 2 minus 1, 8 e to the 3x, which basically is, so when you get u2 na, u2 prime, this becomes negative 2 e to the 3x over e to the 4x. I'll just simplify that to 2 over e to the x. That's u2 prime. Same thing sa u3 prime, nag-cofactor expansion ako. I will not show it na this time. Kasi cofactor lang din siya. You end up with 2 e to the 2x over e to the 4x. Basically, you will end up with 2 over e to the 2x. So this is our u3 prime. So now we have u1 prime, u2 prime, u3 prime. Now, we have to solve for all of the u's. Kasi di naman yung u prime yung hanap natin. So, this one, I did ID. Oh, wait. I'll show it. So, this is integrate both sides. So, magiging u lang to. u1. And this one is IDP, where u is x minus 1 and du is e to the negative x, because this is e to the negative x. In this case, I used tabular method. I personally recommend it. I don't like doing it the normal way. Kasi this is just way more efficient kung oscillating siya like E. So basically differentiate this pababa. So nag-oscillate siya, and then this becomes 1, 0. And then, yeah, so then basically, this will just end up being negative 2x e raised to negative x. So you will see later mag-canceling e. Doing the same IDP here, I'll just leave what I used as, I know, for this case pala, it's just, di pala to IDP, simple integration lang. The simple integration, u2 is equal to negative e raised to negative 2x. So yun lang yun. I know, sorry, this is u2, so negative x lang pala. Sorry, I used the wrong one. 2e raised to negative x. For u3 naman, actually, they're both just integration. So in this case, this is also just 2e negative mawawala yung 2 kasi you will use u sub here. U is equal to 2x, du is equal to 2 dx. So then you have 2 e to the u, which will then become uh, negative e, negative 2x. That's just u3. And then what you will do is plug them all back in sa yc natin. So recall, our yc is equal to c1 e raised to x plus c2 x raised to ex plus u3, plus c3 e raised to 2x. So that was our yc from kanina. We solved this by um, deducing yung nasa table. So now, let's plug in u1, u2, and u3 in place of c1, c2, and c3. So now our yp is equal to negative 2x e raised to negative x e raised to x. This will cancel. That's typically a good sign na you solve it correctly if magka-cancel siya. u2 is 2 e raised to negative x times x e raised to x. So that will also cancel. Plus, what is our u3? Plus negative e raised to 2x, negative 2x, e raised to 2x. So this will cancel also. So you end up with negative 2x plus, oh sorry, di pala yan mag-cancel lahat. Ito lang at ito. So 2x minus 1 kasi may 1 pa dyan. So therefore, your yp is just equal to negative 1, which is super suspicious during the exam. I'm not gonna lie. So then our complete solution is just yc plus yp, which is equal to c1 e to the x plus c2 x e raised to x plus c3 e raised to 2x minus 1. So then that's just the full solution for problem 1. Okay, I saved a bit of space. So, ayan. I think we'll discuss bonus 1. We couldn't backtrack in bonus 2, but we'll solve bonus 1.
Okay, hello. Bonus 1. Mabilis lang to, guys. We're almost free. Free. Okay. Oh, my dog's barking. Anyway, so question is just to set up a system of two LDEs of one dependent variable each. Okay. To solve this system, so yung given is two LDEs, but there's two dependent variables. Both of them have X and Y. So what we're just gonna do here is first thing you can do, separate or group out yung Y's or yung Y's and X's to make it obvious kung ano yung coefficients ng Y. So d over dt x. And then in any case, like with the differential equations, be careful with yung d over dt. Like for example, if it's a second derivative, hindi siya dy over dt squared. It is d squared y over dt squared. Ganon. I don't know how they would be able to. The screen is not updating. Yeah, I don't know how they would incorporate that in Mulcho, but if you make that mistake in the exam, there was deductions. I can say from experience. Anyway, so let's make our coefficient matrix. 2 d, d plus 1, d plus 2. Bakit mabagal na siya? Anyway, x, y plus c1. Okay, so now, wow, ang bagal niya mag-update. That's so sad, guys. Anyway, what the heck? Okay, Sana okay na. So we're gonna separate. We're gonna do Kramer's rule basically. So first, let's get yung determinant of A, which is gonna be 2d plus 4 minus d squared plus d. Or in other words, you can just 2d plus 4 minus d squared minus d. Having A1, it's gonna be, you replace this B1, b plus 1, b plus 2. Sorry, my penmanship is so bad. Okay, and then it's gonna be dt plus 2t minus d minus 1. So in the case of this one, yung A1, you can already simplify yung these, since these are derivative operations. You can make it so d over dt of t is gonna be 1, then plus 2t, then d over dt, this d here is d over dt of 1, which is just 0 minus 1 equal to 2t. For this case, we don't do it A. I'm not sure about the exact reasoning, but basically we need to preserve the d's there so that we can make our LDEs. So then A2, 2, D, T1, 2 minus dt, 2 minus 1, because d over dt of t is 1, plus 1. So, tapos, we can also say, so since we have this A1, we call it determinant of A1, is x is equal to A1 over A. It's going to be equal to 2t over 2d plus 4 minus d squared minus d. And then what you're going to do here lang is, sorry, multiply the denominator on both sides. Then you should just get 2d plus 4. You can simplify this pala. So d plus 4 minus d squared. About 2d minus d. Yeah, makes sense to me. D plus 4 minus d squared times x equals 2t. And then same logic here, since y is equal to 2, it's just 1, equal to 1 over 2d plus 4 minus d squared minus b. Transfer it. Get 2d plus 4 minus d squared y equals 1. And then this is going to be your system. D plus 4 minus d squared x equals 2t. D plus 4 minus d squared y equals 1. Ayan. So awesome.